right, welcome to class, everybody. I hope you guys are having a good day. So one announcement. So the test closed on Monday, but apparently there was a typo in Canvas that said that it closed yesterday. So if you didn't take the test because you were planning on taking it on Tuesday, but it wasn't actually available on Tuesday, but in Canvas it said it was, then you can take it during my office hours. So hopefully that didn't apply to any of you, but if you did if you saw my mistake with the typo, you're welcome to take the test during my office hours. So our lesson today is about how to find quadratic equations when you're given the solutions. So what we've been focusing on for the last couple lessons is how to find solutions to an equation like this. So one way we can find solutions to an equation like this is we can factor the equation. So we can say, okay, well, if I do negative 16 times x squared, that gives me negative 16x squared. What are two things that multiply to negative 16x squared and add to negative 6x? Yeah. Perfect. Yep. Because negative 8x times positive 2x would give you the negative 16x squared, and negative 8x plus 2x gives you the negative 6x. So then I can do factoring by grouping. And this is actually what we did last unit, but it is relevant for our lesson today. So if I do factoring by grouping, the second group has a 2 in common. And when I pull out the x minus 8, I get x minus 8 times x plus 2 equals 0. So this equation and this equation are the same equation. They're just in different forms. So this is standard form and this is factored form. So now that we have it in factored form, how could we find the solutions for that? Yeah. Perfect. Yep. Because essentially we say, well, this times this equals 0. And the only way that you can have things multiplied together to equal 0 is if one of those things, or sometimes more of them, equals 0. So what would make this factor equal 0? 8. Perfect. So we have x equals 8. And then what makes this factor equal 0? Negative 2. So this is kind of review, but these two things would be our solutions because those are what make this equation true. So this is one way you can solve it. The other method that we've learned is to do completing the square. So if we wanted to complete the square for this, we would move the constant to the other side and we'd have x squared minus 6x equals positive 16. And then what is my perfect square going to factor to? Like what is the inside of my perfect square going to be? X minus what? Perfect. Yep, I'll do x minus 3. Because remember, whatever this number is, you want to take half of that, and that's the number that goes here. But this does not factor to this because we're missing a constant. What constant is missing here? A 9. So I'm going to add a 9 to both sides of the equation because if you do negative 3 squared, that gives you the 9. So again, this is just kind of review of what we did a couple lessons ago. And then once we get it to this point, then I say, well, 16 plus 9 is 25. And what's my next step? Yep, so I'm going to, actually, I'll do this in a different color. So I'll square root both sides. And that gives me x minus 3 equals either positive or negative 5. And then my last step would be to add 3 over. And I get x equals 3 plus or minus 5. And since this doesn't have any imaginary numbers or square roots in it, you can actually simplify this further and say x equals 3 plus 5, which is 8, or x equals 3 minus 5, which is negative 2. And notice that these solutions that we found with this method are the exact same solutions we found with this method. So you can use either method, but sometimes this one won't work just because you can't factor the equation. Like if you end up with imaginary solutions, I mean, I guess you could factor it, but this method of factoring wouldn't work. So you can do either one of these methods. And then what we learned in our last lesson was the quadratic formula, which basically does this process for you. So with the quadratic formula, you would look at an equation like this, and you would say A equals 1, because that's the coefficient of x squared, B equals -6, and C equals -16, and you'd plug it in and simplify it. And basically, it would give you the same calculation. The formula just does the completing the square process for you. So what we're doing today is we are taking solutions and turning them into equations. So we're essentially doing one of these two processes backwards. So if we look at this type of solution, so if we end up with x equals 8 and x equals -2, first of all, let's look at how could we get from here back to here. So like if you were given these two things, and ultimately we want to get back to this, how could we work backwards through these steps? Yeah.
Yes. It's like instead of you just subtract 8 to the other side, you get 0 on the other side.
Perfect.
After that.
Yep, exactly. So essentially you take one of your solutions and you say like, what factor will this solution make equal 0? So you say, well, if x equals 8 is a solution, then I need to have x minus 8 because that will equal 0 when I plug this in. And same thing here, x equals -2. If I plug this into here, I know that I need to have an x plus 2 factor because -2 will make this factor equal 0. So the way that I get from here to here is I basically find a factor for each of my solutions, and then I write that out and say that has to equal 0. And then you would FOIL this, just like you said, to end up back here. Is everybody good with that? Kind of an idea? Okay, now, so this is really easy if you have like whole number solutions like this. However, you may have something where the solutions look more like this, and you have an imaginary number or square root or something like this. In this case, we simplified it down to here, so you'd probably want to do the factoring method. But if you end up with something where it's like 3 plus or minus 5i, or something where you have this plus or minus thing going on, then what you want to do from there is basically work backwards through this completing the square process. So the first thing you want to do is get the plus or minus stuff by itself. So like you'd subtract 3 over, which would give you x minus 3 equals the plus or minus stuff. And then you would say, okay, well, to like the way that I got here was by doing the square root. So if I'm working backwards, then I'll square it. And if you square this, you'll end up with this polynomial. And then if you square this, well, a plus and a minus, if you square a positive times a positive equals a positive. And if you square a negative times a negative also equals a positive. So when you square a plus or minus, you just get a positive of whatever this number is squared. Does that kind of make sense? And then from there, so like once you get this all FOILed out and you have the 25 over here, then to get it in standard form, you just subtract it so it's equal to 0. So you'll use one of these two methods depending on what types of solutions you're given. So if you're given two totally different numbers that aren't really related with a plus or minus at all, then you just write out their factors and FOIL it out. If you're given something like this, where you have a plus or minus, then you get the plus or minus stuff by itself and square to get rid of the plus or minus, and then set the equation equal to 0. So let's go through some examples. So if we start off with question 1 on your homework, we have find an equation that has the solutions y equals -3 and y equals 6. So if we want to have those two solutions, then we need to think about, well, what factors will those solutions make equal 0? So let's start with y equals -3. What would be a factor that when you plug -3 in, it makes it equal 0? Perfect. Yep, y plus 3. We can check that. If I took a -3, plug that in for y, would it make the factor equal 0? Yeah. Okay, now the next one, what would make y equal 7? Perfect. So we get y minus 7. And then the whole point of this is that these two things make it equal 0. And so if these are solutions, when you do either -3 plus 3, that makes this 0, or this is 0. When you multiply them together, it's going to equal 0. And this is really important because they asked for an equation. When I was working with my last class, they would like FOIL it all out and they did everything right, but they forgot to make it an equation and set it equal to 0. So remember what they're asking for. You want an equation where you're going to have some polynomial equals 0. So then from here, this is the equation we want, but they said they want the answer in standard form. So to put it in standard form, we basically just FOIL it out and we get y squared minus 7y plus 3y minus 21 equals 0. You can combine the like terms, which gives you y squared minus 4y minus 21 equals 0. And that would be your final answer. So essentially, we're just like working backwards from everything we've done so far, because before our goal was to take something like this and find the solutions. Now they're giving us the solutions and we're finding the equation that has those solutions. Any questions on this so far? Yeah.
We have understood why do you switch it to instead of -3 to +3?
Yeah, good question. So we're not having, so the -3 needs to be a solution to the equation, which means that when we plug -3 in, it needs to make the equation true. And so the whole way we set this up is so that this factor equals 0. So you get 0 times something equals 0. So then y equals -3. If you do -3 plus 3, that's what makes it 0. Versus if this had been y minus 3, you have got -3 minus 3, which gives -6. And that won't make it a solution because -6 times -10 or whatever doesn't equal 0.
But the negative has to go somewhere.
Yes, the negative is what y is. So y equals -3. If you put that in, that makes, like, the -3 isn't going in here. The -3 is going in for y.
What about the +7?
So the +7 is going in. So like,
Oh,
there's two solutions to the equation. So like if I put in a -3, I'd get -3 plus 3 is 0. -3 minus 7 is -10, but 0 times -10 does equal 0. So that's one possibility. The other possibility is if y equals 7, then you would get 7 plus 3 is 10, 7 minus 7 is 0, but 10 times 0 does equal 0. So they're kind of like two separate situations.
Okay.
But both of them have to be solutions. So you have to build your equation in a way that they both end up being solutions. Yeah, good question.
So that's the answer.
Yes, this equation is the answer. Yeah. Okay, so that one's relatively, well, once you understand the concept behind it, hopefully that should be pretty easy. How are you guys feeling about that? Good, okay. Let's do one where you're given a fraction. So in this case, we want to find an equation that has a solution y equals 1/6 and y equals 8. So we can build the first or the second factor relatively easily. It's just going to be y minus 8, right? Because 8, if you put that in, 8 minus 8 will equal 0. And for the 1/6, you could set it up and do y minus 1/6. However, when you FOIL this all out, that's going to get kind of messy because you'll have like a -1/6y and a -8y that you have to combine like terms, and then you'd have to find common denominators, and it would just be messy. So another way that you could write this factor that would make it so you don't have to have a fraction is you could write it as 6y minus 1. Because if you do 6 times 1/6, that will equal 1. And if you subtract 1, that will equal 0. So this one will be easier to FOIL. So I would recommend writing your factor like that. You can write it as y minus 1/6, but I think it's easier if you write it like this. Any questions about how I got that factor? Also, if you're not sure like how to get that, one way you can do it is you can say, well, I ultimately want y minus 1/6 to equal 0. And then you can multiply that little like mini equation by 6 on both sides, which gives you 6y minus 1 equals 0. So if you're not quite sure how to set up this factor so that it cancels out, that you can start off by writing y minus 1/6 and say I want to have it equal 0, and then multiply both sides by 6. Okay, so these are my two factors, and when I multiply these two factors together, I set it up so that they'll equal 0. So then you just FOIL it out and you say, well, 6y times y is 6y squared. 6y times -8 is -48y. And -1 times y is -y. -1 times -8 is +8. Then you can combine like terms and you get 6y squared minus 49y plus 8 equals 0. And if you ever want to check and see if you did it correctly, you can always take these numbers and plug them into this equation and make sure they really do make them true. Because the whole point is to write an equation that has these two solutions. All right, any questions on how to do it when you have fractions? Okay, so now let's talk about how to do one with like the plus and minus stuff. Okay, let's do this one. So on this one, we have two solutions. We have x equals -4 plus 3i, and we have x equals -4 minus 3i. Now, technically, you could do the factoring process on this. So like you could say my solutions are going to be x plus 4 minus 3i for the first solution times x plus 4 plus 3i and have that equal 0. However, this is a little bit complicated because you're basically going to have to FOIL or like distribute 3 times. So I wouldn't recommend doing it this way, but you could do it this way if you wanted to. The easier way that I would recommend is to essentially undo completing the square. So to undo completing the square, I'm going to first write these two solutions in a single equation. So the way you do that is you say, okay, well, x equals -4 plus or minus 3i. Because basically these two solutions are almost the same. This one's just a plus 3i and this one's a -3i. And then you basically work backwards from completing the square. So if we go back to this place where we completed the square, the way that we would work backwards from this place, because this is essentially where we're at, we would subtract 3 so that the plus or minus stuff is by itself. So we'll come back over here. And in this case, what would we do to get this plus and minus stuff by itself? Add 4. So we'll do x plus 4 equals plus or minus 3i. And the plus or minus came from taking a square root. So to undo that, we'll square both sides. And when you do x plus 4 squared, you get x squared plus 8x plus 16. This is from FOILing it out. I kind of just did that in my head. Do you guys want me to write that out? So like this 8x came from like when you do x times 4 and 4 times x and combine the like terms. And then when I square this, well, a positive or a negative, if you square it, it will equal a positive. So plus or minus, when you square that, will become a positive. 3 squared is 9, and I squared is what? -1. So if I have a positive 9 times a -1, that will ultimately give me a -9. Everybody good with that? Okay, so this is my equation, and to have it in standard form, I just need to have it equal 0. So I'll add 9 to the other side. Whoops. And that would give me 8x squared plus 8x plus 25 equals 0. And that would be my final answer. Any questions on that? So again, basic strategy is if you have two totally different numbers as your solution, like -3 and 7, like those can't be written in plus or minus form. Well, I guess technically you could, but like, I don't actually know what the answer. I think it'd be like 2 minus 5 and 2 plus 5 maybe. But like you'd have to kind of think about it to see what number like you could plus or minus to get these two. So if you have two totally different numbers that don't off the bat look like they could be written as a plus or minus, then you write out the factors and FOIL it out. If you do have something where you can write your answers in a plus or minus form, then you get the plus or minus stuff by itself. Like in this case, we added 4 to the other side. And then you square the plus or minus stuff, and then you make the equation equal 0. Let's do another plus or minus example. Let's do this one. So in this one, the two solutions are already written in plus or minus form. And what do you guys think the first step would be to solve this one? Times by 2, yep. So that will give us 2x equals -1 plus or minus 4i. Then what would my next step be? Yep, add 1, because I want to get the plus or minus stuff by itself. And now I have that. I have plus or minus 4i. What do I do next? Yep, square both sides. And when I do 2x plus 1 squared, let me FOIL that out. So 2x times 2x equals 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is 1. So that gives me 4x squared plus 4x plus 1 equals plus or minus squared is a positive. 4 squared is 16. So I have positive 16 times I squared. But what's I squared? -1. So if I do positive 16 times -1, that will give me -16. Then my last step is just to make it equal 0. So I do 4x squared plus 4x plus 17 equals 0. And that's how you do that one. So that's pretty much it, what you'll be doing on your homework. So you have some problems where the solutions are like plus or minus situations, and you have some where they're factors. On question 11, you have one where there's 3 solutions. So on question 11, based on the way that it's set up, how do you guys think you would write the equation for that one? Did you say t minus 3? Okay. Perfect. Yep. So on this one, because they're like, I mean, these two are plus or minuses of each other, but this one isn't. And so since you have like 3 of them, then you just want to set it up in the factored form and then FOIL that out. So if you FOIL the first 2, you get t squared plus 3t minus 3t minus 9. And that is multiplied by t plus 4 equals 0. But that can actually be simplified because that gives you t squared minus 9. And then you'd multiply that by t plus 4. And when you FOIL that, you get t cubed plus 4t minus 9t minus 36. And so this equation would be your answer. So essentially it's the same as the ones that we were doing earlier. You're just going to have 3 factors instead of 2. And it takes a little longer to FOIL it out because you have to do 2 sets of multiplication. So that's it for our lesson today. If you have any questions on this, or if you have any questions on yesterday's lesson, let me know. But I'll let you guys get started on your homework.